Now let's solve problem D. To solve this problem, first we solve the case where we have only two vertices. So k is 2. When k is 2, we just want to maximize the max of the path between these two vertices. So what we do is we want to select a path that has 0 in it, 1 in it, 2 in it, and so on. So we want to have as much as possible vertices in our path. So consider the answer be x. It means that there is a path where 0, 1, 2, and 2x are in the path, but there is no path that 0, 1, 2, and so on, and x plus 1 are in it. Okay? So first, we want to find the maximum possible x. Let's do it. So for finding that, I will tell you how we will find that very soon. So bear with me, I will show you. Okay. So to do this, what I do is I define vector answer, which is 0, 0. It means that the answer, the answer that is the path, it starts from 0 and goes to 0. So I update this path every time. So one by one, I try to add the new vertex that I see to this path. And if I was able to do that, I will update the answer. So what I do, let's name it CER, means certificate, and ends B1, and then let's define some mark that I will tell you, and then let's do DFS on all of vertices, and let me define R, which I will tell you what it does, and then if U is not key, I will do this parent. I will set parent of U, and then I will do the DFS. Okay. Then let's start to add other vertices to see how many vertices we can add. And also let's mark the first. So I have a CER, which is the certificate. Certificate means that how I achieve this answer. So the current answer is 1, right? I took 0 to 0, so both vertices are 0, and answer is 1 because the max of this path is 0, and it works, and it's okay. So I'm gonna add vertices one by one. I have an array mark, and what does it mean? So mark means that, let me reset it before I forget. Okay. Okay. So mark means that this vertex is on the path. So if I is already marked, I add 1 to the answer and I continue. Otherwise, I know that I is not in the path. So when I is not in the path, what I do is I I need to see if I can add it to the past. So how? I will define v, which is equal to I, and then while not mark v, I will mark v, and then I will go to parent of v. So then I will see if I can find v in ser. What does it mean? So I had some v, I started to go up in the tree, and finally I will reach some vertex that is already marked. Why? Because at least we know that 0 is marked, right? So if I start from any vertex that is not marked and go up, finally I will find a vertex that is marked. Easy, right? So if that vertex is one of the endpoints of the path, I can update the endpoint of the path to I, and this new path contains I minus 1, I minus 2, and all of the vertices until 0. But if the vertex I reach is a marked vertex, but not one of the endpoints, for sure, I can't add I. So if I can't find v in ser, it means that I need to break. That's it. Otherwise, I will set that endpoint to I, and I will add ans by 1. So finally, I print the answer. Okay, but let's continue. Let's see what is the answer when k is 3, 4, 5, and so on. So look, consider k is 3. I have 3 vertices. Consider that for every path I consider between these 3 vertices, 0 is on them. But it can't be possible that 1 is also on all of them. So what you understand is for k3 and more, the answer is at most 1. So knowing that, let's see how many k's have answer 1. How many? So consider 0 and the neighboring vertices. I can, if I want to choose more than this number of vertices, for sure answer will become 0. So if k is at most g0 dot size plus 1, I will print 1, and from that number on I will print 0. So let's start with k equal to 3 and go to n and see out k is less than or equal to g of 0 dot size and a space here, and finally an end line, end of line. That's it. And index out of 1. Why? Because we don't need to decrease them by 1. And let's move on. 3, 1, 0. Why? Like this. 3, 1, 0, 0. But it needs to be 4, right? So answer is at the beginning 1, and if it's marked, so let's see what happens. 0, 1, 2, 3 is the answer. Let's put a breakpoint here to check out there. Okay, sir is 1 and 2, 1 and 2, which is incorrect. It needs to check with 3, but let's see what happens. So when it becomes 3, let me come to this. So I is 1, I is 2, I is 3. Okay, I is 3. And now there is 1 and 2. That's good. Let's come to here. Now 1 and 2 and 1 and 2 and V0. Oh, that's unbelievable. So let's check the current of 3, which is 0, which is incorrect, right? Current of 3 is the current of U is V. Oh, sorry, I didn't call it yet. Okay, go ahead. I didn't call it yet. Okay, that's true, it's working. So let's do a magic trick here to make sure we reset everything. That's good. Let's proceed. Problem D and submit. While it's submitting, let's see. It's correct. It's good. Good. Let's see. They are all good. Let's see. Okay, go ahead. Seems all good. Waiting for AC. Waiting for AC. Waiting for AC. And finally AC.
Thanks for watching. If you found this video useful, please like, subscribe, and ring that bell. By the way, YouTube thinks the video down here is just perfect for you. Give it a watch and let me know in the comments.